So this first part, it's really just practice, right? It's kind of like a boxer hitting a punching bag. It seems pointless, but at the end of it all, he's improving his skills, right? Right here, we're going to practice expanding with the properties. So on number 1, it says log base 2 of 25. Now notice that the instructions say use log base 2 of 3 and log base 2 of 5, and they give you the decimal answers to those guys, right? So the question is, could we manipulate 25 to either become a 3 or a 5? We could manipulate it to become a 5. So let's do this. I'm going to zoom in, and we're going to change it to log base 2 of 5 squared. So normally, before, we would want this to be base 2, so log base 2 of 2 cancels out. But because they give us log base 2 of 5 on the instructions, we're going to be able to manipulate or replace log base 2 of 5 with a decimal. But right now we're going to use which property? What property could we use to change the way this looks? The product property, the quotient property, or the power property? Power, because we have a power of 2 right here. Now the power property, what does it say? You could take the power and put it out in front with multiplication. So I'm going to take this 2 and put it out right here in front with multiplication. So I really have 2 times log base 2 of 5. Now if we take a look at our instructions again, log base 2 of 5 is 2.3219. So let me take that 2.3219 and let me replace the log base 2 of 5. So there it is. I've replaced it. 2 times 2.3219. Now with the calculator, 4.6438, and that is your final answer. If you flip the paper over, you could also see that that is the correct answer. Ladies and gentlemen, now like I said, our Casios actually do this stuff. So you could have actually typed in the base 2 right here in the base spot, the 25 in the parenthesis, and you hit equal. It should give you something close to that. But you see, you're kind of defeating the purpose of working out here, of practicing. What we want to do is look at these things, look at what they give us, so we could actually manipulate it to use the properties to change the way they look. So we're practicing here, all right? So, for example, let's jump to this one. What property do you think we're going to use on this guy? The quotient property, right? Now there's the product property, which means multiplication. There's the quotient, which means division. And there's the power. Do you see any powers right here? No. Do you see any multiplication? Not really. You have division. It's really a fraction, 3 divided by 5. So the quotient property allows us to take one logarithm and split it into 2 logarithms. Okay, so we're going to make it, this log base 2, we're going to put log base 2 of the top of 3. Now, if you're not following me, check this out. Here's the quotient property. It says when you have log of something divided by something, you could write this log of the top minus log of the bottom. That's what the property says right here. You see it? Log of m minus log of b. Log of m minus that same log of n. I'm sorry, n, not b. So log base b of m minus log base b of n. That's what we're doing. We're using the quotient property. So we're going to go log base 2 of 3 minus log base 2 of 5. You guys with me? Now, again, why are we doing this? Because log base 2 of 3, I don't know that answer. Log base 2 of 5, I don't know that answer. I know log base 2 of 2. I know log base 2 of 4, log base 2 of 8. But I don't know log base 2 of 5. But wait a minute, I do know log base 2 of 5, and I do know log base 2 of 3. Why? Because they give that to us in our instructions. They tell us log base 2 of 3 is that, and log base 2 of 5 is that. So all we got to do, since they give us those values, is replace log base 2 of 3 with the decimal 1.5850 and replace log base 2 of 5 with 2.3219. So let's do that. Let's replace them with the decimals. So I really have these values, 1.5850 take away 2.3219, and let's do that on a calculator and we'll get, so there is our final answer. Okay guys, so this first part is just practicing the properties, right? I know you're thinking, why the heck do I want to do all that stuff if I could just use the Casio and type in the base 2 and type in 3/5 as what I'm taking the log of, right? So if you look right here, you could type in the 3 divided by 5 right in here. 3 divided by 5, you could type in the base 2 right there, and you could get your answer that way. But you see, the whole purpose of this is just to practice the properties, okay? So let's move on to something more fun, which is the next section, which is solving equations. Okay, solving equations. Now, we've solved equations before, but this time it's going to be a little different, right? Like, for example, last week we had logarithm equations where we simply raised both sides to be the power of base 6. But see, the problem here on number 14, you can't get rid of the logs by raising it to be the power of base 6. If you put a 6 right here and a 6 over here, yeah, this would cancel, but over here it would not cancel. Because in your exponent position, there's a plus sign, which really means that you have 6, it just gets all messed up, okay? So you can't do that unless you have a single log, but since you have pluses and other terms, you're not going to be able to just raise both sides to be base 6, to get rid of the log base 6. So last week we had easy equations. These are a little bit more fun. Now what do I mean by a little bit more fun? We're going to have to use the properties. So if I just focus in on the left side of the equation, I do have log base 6 of something plus log base 6 of something. So because I have both log base 6's and because I have a plus, that should indicate, if I have the properties memorized, which property am I going to use? The product property. Now the product property says if you could split them or you could go back and condense them. I'm going to condense them. So I'm going to take both of these log base 6 and write them together as one single log base 6. And all we have to remember of that property is that if you put them together, you have to take this 2c and multiply it with 8. So now I have 2c times 8. What's 2c times 8? 16c. So on the left side of the equation, here's my equal sign. On the left side of the equation, I really have log base 6 of 16c. Now on the right side, let me just bring it down. I'm just going to bring down the log base 6 of 80. So now I do have an equation that has a single log base 6 on this side, a single log base 6 on that side, and now I am able to raise both sides to become the powers of base 6. That way this cancels, I have a simple equation that says 16c equals 80, and all I have to do is divide both sides by 16, and we will get the answer c equals 5. Ta-da! What do you guys think? Let's jump to number 12. Check out number 12. Well, I know we're thinking, well, let's get rid of log base 7. Raise both sides to be the power of base 7. Why can't we do that yet? Because there's a 3 out here. This is really saying 3 times log base 7 of 4. The only way we could actually raise both sides, if you had log base 7 of something equals log base 7 of something. Then you could raise both. But you have a 3 times out here in the front. That messes it up. So what property could we use to get rid of this 3 that's out in front? The product property, the quotient property, or the power property? Power property. So we're going to take this 3 and we're going to use the power property to condense it, move that 3 up here and make it to be a power of 4. So what happens now is that we have log base 7 of 4 to the third, and if we do the same to the other side, take this 2 and make it a power of b, put the 2 up here, you'll have equals log base 7 of b squared. And now, of course, you could raise both sides of your equation to become powers of base 7. So you put a 7 here, a 7 there. Now it cancels out. So you really have 4 to the third. What is 4 to the third? That's 64 equals b squared. Right? The b squared just comes down. And now it becomes a simple equation that you could solve that has no more logarithms. So you'd apply a square root on both sides. So you'd have b equals, and technically, since you're applying a square root on an equation, it should be plus or minus 8. However, you're supposed to check your answers. I'm not sure if I did that on the last one, I'm sorry. But we're supposed to check our answers. If we do put a plus or minus 8, that means that it could be a positive 8 or a negative 8. Now, if I plugged in a positive 8, right here, I'd end up with the logarithm of a positive number, and that's cool. But if I plug in a negative 8 right here, it's going to be logarithm of a negative number. We know that that can't happen, right? So it's really just positive 8, not negative 8. B equaling negative 8, that would be an extraneous solution. So you always want to go back and double check your answers. Make sure you don't end up with negatives inside your logarithm. Jumping back to number 14, we got an answer of 5. If you take 5 and put it in here, 2 times 5 is 10. That's not a negative, so you're cool right there. And there is no other C's to plug in, so you know that that's not extraneous, right? So always go back and check your answers. Make sure you don't end up with negatives inside your logarithms. All right, 18 looks like some fun. Why? Because we're going to apply different properties, all right? Let's look at the left side of this equation first. And see, the problem is I have too many logs. I just want 1 log base 8 on this side, 1 log base 8 on that side. That way I could raise both sides to be powers of base 8. That way they cancel out. So let's just focus in on the left side of this equation first. Let's condense. What properties could I apply to condense it, to make it smaller? Power property, absolutely. I want to take this 3, raise it up to be the power of the 2. So the 3 is going to really become 2 to the 3rd, right? So this is no longer there anymore. Let me rewrite it. Log base 8, and instead of writing 2 to the 3rd, what should I write? What's 2 to the 3rd? 8. Bring down the log base 8 of 4, and actually this becomes a pretty easy problem here. Oh no, it doesn't. Because one thought, at least for me right now, was cancel this out, right? That's my thought, cancel it out. But if I did cancel it out, then I'd end up with, so don't cancel it out, right? I'd end up with 1 minus log base 8 of 4. And when you try to raise this to be the power of base 8, it's not going to cancel out because of this 1 that's out in front. So that's the wrong thing to do. Let's continue condensing using our properties. What other property could we use to make this even smaller and nicer? The quotient property, that's right. So I'm going to take this log base 8 and this log base 8, and I'm going to put them together. And when I do put them together with the quotient property, this first term goes up on top as a numerator, the bottom, this next one goes on the bottom as a denominator. And of course, 8 divided by 4 is 2. So on the left side, that whole left side of the equation, it ends up log base 8 of 2. So I condense the whole left side. Let me bring down the equal sign. There's my equal sign. Now let me look at the right side of this equation. On the right side, we have log base 8 of b. Let's just bring that down. So I'm going to take log base 8 of b and rewrite it down here. Log base 8 of b. And now we could actually raise both sides of this equation to become powers of base 8. 8 right there, 8 right there. That cancels, that cancels. What's left? Your answer, 2 equals b. Ta-da! Of course, we need to double check it. We need to substitute and make sure there's no negative values inside the logarithms. 2, where do I plug it in? There's no variable, just right here. And this is going to be the logarithm of 2. That's fine. As long as it's not negative, we're good.